In this video, we will try to learn how to solve an ISLM model using the matrix inversion method. The question is like this. Let the IS equation be, that is y is equal to a divided by 1 minus b minus g divided by 1 minus bi, where y is the income and I is the rate of interest, and we are also given the LM equation like this. And we are also being given the value of a, g, b, m naught, k, I. Okay, sorry, this capital I, which is the investment, m naught is the money supply. I will not go into the details. What does these variables tell us? I have actually made the videos on ISLM model. Okay, you can check them out. The question tells us if b is equal to 0.7, g is 100, a is equal to 252, k is equal to 0.25, I is 200, m naught is 176. Write IS LM equation in matrix form. We have to write this IS and LM equation in matrix form, and subsequently we have to solve for y and I by matrix inversion. We have to find the equilibrium level of income and interest rate using matrix inversion. Okay, first of all, what will we do? We will just take these two equations and plug the values. Okay, so I will write here to make to save space. Our y is equal to, in place of a, the value of a is here 252, so I will write 252 divided by 1 minus b, that is 1 minus the value of b is given, that is 0.7, 0.7, and we know that b is the marginal propensity to save, minus, we have minus g, sorry, in place of g we have 100, so I will write here 100 divided by 1 minus 0.7. Okay, I. Okay, this is our IS equation. Similarly, we will write here y is equal to, and put the value of m naught k. Our m naught is 176 divided by 1 minus 0.7 plus we have I is equal to 200 divided by 1 minus 0.7 times I. Okay, when solving these two equations, I have already calculated these values, so it comes out to be y is equal to 840 minus 333 I. This is our IS equation. Okay, our LM equation comes like this. Y is equal to, when solving this very thing, we got 704 plus 800 I. Okay, further we can write this like y transposing this negative 333I on LHS, this will become positive 33I is equal to 800. Okay, what we did here, we took all the endogenous variables on LHS and exogenous variables on RHS. Exogenous here is this 840. Similarly, in the LM, we will take all the endogenous variables on LHS, that is why we have minus 800 I is equal to 704. Okay, so I forget to write 3 here. Now, to write them in matrix form, how do we write them in matrix form? I have made the videos on matrix algebra also, you can check there, but I will show here. We write in matrix form like this: a times x is equal to b. Okay, where this a is called the coefficient matrix, this x is the solution vector, and b is the vector of constant terms. Okay, this a is simply, I will write a is simply the coefficients of the endogenous variables. Here the coefficient of y is 1, I will write 1. Coefficient of I is 333, I will write 333. The coefficient of y is 1. The coefficient of I is minus 800. Okay, so this is our A, which is a coefficient matrix. Similarly, our x, this x is the solution vector. It comprises of here obviously the endogenous variable y and I, which we have to find. Okay, and this b is simply the vector of constant terms. In here, in this case, these are these two numbers. Okay, 840, 704. Okay, so we have written, we can write then them in a matrix form like this. I will write here, this is 1 1 3 3 3 minus 800 times y I is equal to 840 and 704. This is the answer to this first part, that is writing the ISLM equation in matrix form. So we can write them in this very form. Now the question tells us to solve for equilibrium level of income and rate of interest. For that we need the matrix inversion formula. What is the formula? The formula is simple. I will write here. How do we find? The formula is simple. X is equal to A inverse B. Okay, here this X is the solution vector, B is our new the vector of constant terms, and A inverse we have to find. How do we find A inverse? A inverse is equal to 1 divided by determinant of A times adjoint of adjoint A. Okay, so we have to find many terms here. First we find the adjoint. Okay, we have to find the adjoint of this very matrix. So adjoint is simple. How do we find the adjoint? Adjoint is simply we take the product of these two numbers. Okay, these two elements, these are also called the principal diagonal elements, and we multiply them. That is 1 into 800 minus 800, so this will become minus 800. Okay, then we have minus 1 into 3, then we multiply these two elements. Okay, so this is 333 times 1 is 333. Okay, which comes out to be 1133, but negative, and it should not be equal to 0. Here we can see it is not equal to 0. If it was 0, then we cannot solve this very system of equation. Okay, or rather our solution would have not been feasible. So we got this A. Now we have to find adjoint. How do we find adjoint? Adjoint is simply adjoint of A is simply given by, if we have to find the adjoint of a 2 by 2 matrix, it is very simple. What we do, we just interchange these two numbers. We swap their positions. Okay, the numbers which are on the principal diagonal, we swap them. So this minus 800 will come to this very top left corner. So this will minus 800, and this one will come down. Okay, so first rule is swap the principal diagonal elements, and what we have to do these with the remaining elements, we have to do nothing. We have to just write them as they are. This is 333, and we have 1. Okay, but we have to change their signs only. So since it is positive, it would be negative. Similarly, if it is here positive, it will become negative. Okay, so this is very basic rule. Rather I would say shortcut, but this doesn't hold for a 3 by 3 matrix or any other matrix of order greater than 2 by 2. Okay, it only holds for this very 2 by 2 matrix, this very trick. And the trick is simply we interchange the principal diagonal elements and change the sign of the non-principal diagonal elements. Okay, so this is the adjoint. And I repeat here, this truth doesn't hold for a matrix of uh, 3 by 3 order, or order greater than 2 by 2. Okay, just want to show that I am not making anything wrong here. So this is our adjoint, which implies our A inverse is equal to 1 divided by this what we have got here, minus 1133, this determinant times adjoint. So I will write here adjoint is minus 800 minus 333 minus 181. Okay, when solving this, that means this minus 1133 is divided to every element. Okay, so I will write here, so this is minus 800 divided by minus 1133, and we have minus 33 divided by minus 1133. Similarly, we have minus 1 divided by 1133, and we have 1 divided by minus 1133. Okay, when solving this comes out to be, that is A inverse comes out to be, when solving this negative negative gets cancelled. Okay, here this negative negative gets cancelled. So when solving, we get here 0.7061, similarly minus 0.2939. I have calculated these numbers. Also 0 minus 0.001, and we have minus 0.001. Okay, this is our A inverse. Sorry, here it is positive, this is positive. Now we have to use this very formula. The formula is simple, so I will just write x, which obviously is the y and I is equal to A inverse. Our A inverse is this very matrix, that is 0.7061. We have 0.2939, we have 0.001 minus 0.001, and to this we have to multiply b. B is our vector of constant terms, that is 840 and 704. Okay, how do we multiply? uh, we multiply this first row with this column, that is we multiply this 0.7061 by this 840. So I will not explain everything. How do we multiply two matrices? I have made the videos on the matrix algebra and economics in very simple language, you can understand there also. So we multiply this element with this element. Okay, plus then we have 0.2939, and to this we multiply this 704. Okay, similarly, taking this very row, we have 0.001, and we multiply it by 840, and then we have minus 0.001, and to this we multiply this 704. Okay, when solving, this comes out to be, I will write here, this is a 799 and 0.13. Okay, that means our y is equal to 799 and 0.13, which simply means our equilibrium level of income is 799, and our equilibrium rate of interest is 0.13. Okay, I hope I make myself clear in this video. Actually, this very question can also be solved by the simple algebraic rule.